that'll tie in better. All right. 4-step process. It's on the board, but let's do it again. Let's go through it one more time, and then we're going to do a whole problem with all 4 steps. So to do confidence intervals, first thing you want to do is to state the parameter you're estimating. That's usually, the sentence is usually going to look like, we are using this % confidence interval to estimate, in this case, the proportion. Step 2, you're going to check your conditions. And you're going to say what kind of confidence interval you're making. Right now, we only have one. So it's going to be really easy to pick from. Not all that much thinking required to pick out which one you're using. You're going to use the only one we've done so far. And then you're going to check your 3 conditions: random, normal, independent. Do the calculation. You're going to put in the formula, plug in your numbers, and then get out your interval. And finally, you're going to interpret that interval. We are this % confident that the actual parameter falls between these 2 values. That's the entire process. So we're going to do that entire process for this next example. Here we go. And if you've looked at the calendar, you'll notice that we have a quiz at the end of this week. This is what your quiz is going to be. I'm going to give you a problem, and you're going to do the 4-step process on it. That's what the quiz is going to come out to be. All right, here we go. We want to construct a confidence interval for the proportion P of pennies more than 10 years old in their collection. The sample had 57 pennies more than 10 years old and 45 pennies that were at most 10 years old. Calculate and interpret this 95% confidence interval. Step 1. State the interval that you're estimating. State the parameter that you're doing. A lot of times, this part, a lot of it is going to kind of be copied from the original problem. It's going to be really easy to find. We are using a what percent? 95% confidence interval. To estimate P, and we're going to define what that is. The proportion. I'm literally copying down what was said in the problem of pennies. More than 10 years old in the collection. And just to get our variables straight here, early on, what's n? This is a little bit of a trickier question. 57 and 45, so together, that's the total sample size. 102. And so, P hat, that proportion, out of 102, we're looking for the ones that are more than 10 years old. That's 57. 57 out of the 102. Can I get a decimal out of that? 0.55 what? 0.55, we'll do 0.559. So these are the variables that we're going to use. So that is step one. We're going to say that we're doing a 95% confidence interval. We're going to define the variable that we're estimating here. That is our step one. That's the information that needs to be done and written down in step one. Step two. I'm going to say that we are going to use a 1 proportion Z interval. This is the name of the confidence interval that we're doing, and that's associated with the formulas that we're about to use. This is called a 1 proportion Z interval. You might see the book call it a 1 sample Z interval for proportions, but it's the same thing. 1 proportion Z interval is what we're going to call it. You'll see why in a second. Let me break that down. 1 proportion. We are estimating a single proportion. Z, we're using Z-scores. Interval, it's a confidence interval. So 1 proportion Z interval. Conditions. Random. So conditions. This sample of 102 pennies was a simple random sample of all the pennies.
Where did you pull that from? Because it doesn't actually say that it was
Hold on. Yes, I want to keep the annotations. Oh, look at that. It is almost never that it will violate the random condition. If we're taking a sample and it's asking you to make a confidence interval, it's going to be a random sample. I'm going to talk about that in just a minute. Let me get through the entire 4-step process, and then I want to go back and talk about the conditions and whether they're violated. So random. Normal is our next condition. I don't know why it's doing that. Normal. For normal, don't forget, since we're doing proportions, to check for a normal distribution, we're checking for n times p and n times 1 minus p. N times p hat equals 102 times the 0.559. Well, we have how many successes and failures there are. We know this is 57. That's at least 10. N times 1 minus p hat is 102 times 0.559. Sorry, times 1 minus 0.559. That's going to be 45. the 45 that were not greater than 10 years old. That's at least 10. So since both of these are at least 10, therefore, we can use an approximately normal distribution. Okay. So we did our random, we had a random sample. Normal, we checked n times p hat and n times 1 minus p hat. And so our last one is independent. Which is, we have this collection. We're making the assumption here in doing this calculation that there are more than 10 times the sample size. So 10 times 102. Pennies in the collection. I realize some of the handwriting is sloppy and all that. If you need anything read, I think I said everything aloud that I was writing. But if there's anything that you can't, that you're having trouble with. So we checked that we had a random sample. We checked that n times p and n times 1 minus p were both at least 10. And independent, we're assuming that the population is at least 10 times the sample size. Those are our conditions.
So since we assumed that, can we pretty much for most of these problems assume that it's going to be independent?
Okay, let me talk about these conditions. The way that you can tell, we're always, in this type of problem, going to need to check and show that the conditions were met before we do our calculations. This problem was an unclear example. Usually it'll be clear that the conditions were met. And if you're doing a confidence interval, it is not going to be, there won't be a case of like, oh, the conditions were violated, that means we don't have to do the rest of it. If they want to test your knowledge of the conditions being violated, they will usually ask a question like, one of these conditions for doing a confidence interval is violated. Explain which one it is and why the condition is violated. Or it might ask, instead of asking you to do the confidence interval, it might ask you a question like, check that the conditions for doing a confidence interval are met. And then that starts to really bring into question whether the conditions are going to be met. If it's just asking you to make a confidence interval, you're going to check the conditions and they're going to work. Like almost all the time. I don't want to say all the time in case they throw a wrench in there. But I haven't seen them ask you to just make a confidence interval and then the conditions are violated and we can't actually do the confidence interval. So again, independent says, if you can't see it down there, we can assume that there are more than 10 times our sample size, 10 times 102, which is 1,020 pennies in the collection. All right. Any questions before we do? Those are the first two steps. Any questions before we do the last two steps? Okay. Step 3. We're going to do the calculation. The things you need, the parts you need in step 3, formula plug in the numbers, answer. Those are the things that you need to write in step 3. Formula, plug in the numbers, answer. The formula. Point estimate, or p hat, plus or minus. Our critical value, which is our z-score, times my standard error, which is my standard deviation formula. So the square root of p hat times 1 minus p hat all over n. Plug in the numbers. Our p hat was 0.559. That's what I'm going to use. 0.559 plus or minus. Our z-score, we went through a bunch of these getting the z-score. We did a lot of those in the notes yesterday. And we actually did it for 95% and figured out that it was 1.96. If you don't remember, you can do the inverse norm and work through it that way. Times square root of 0.559 times 1 minus 0.559 all over our sample size, which is 102. So there's the formula. There's plugging in the numbers. Sort of. Answer. Point 462. 0.655. I'll show that in just a minute. There's an easy way to get it out of the calculator. I will show it in just a minute. Let's finish this up and interpret it first before I go to a different screen. Yes? Sorry. Interpret. We are 95% confident. We are 95% confident that the parameter, so what was the parameter again? Right? Copy the parameter you defined from step 1. Right? You already defined it, so you just need to copy it down. The proportion of pennies in the collection that are more than 10 years old. So the parameter. So we are 95% confident that this parameter lies between, and then give my interval, 0.462 and 0.655. Done. So again, that structure of that sentence is, if we're 95% confident that, and then we'll restate what my parameter is between these two numbers. The way that the book usually writes it is something like, they change the order and give the interval and then say the parameter. So that works too. You just need to make sure that you have the three things you need to have in this sentence is saying 95% confident, you need to say what the parameter is, and you need to say that it is in between your interval. So I think the way the book would phrase it is, we're 95% confident that the interval of 0.462 and 0.655 captures the actual proportion of pennies that are more than 10 years old. You'll have these sentences memorized pretty quickly, pretty soon. It is very much a structure, and you're filling in the pieces that you need in that sentence. Okay, questions on any part of this problem? I wanted to make sure I went through the problem and went through everything you need to say. Questions on any part of how we did that, or how we came up with the sentences that we did, or where any of the conditions came from, or any of that?
Are we going to go through one where it's not a proportion, where it's like the...
That's the next section.
Gotcha.
That's 8.3. And then we'll have more than one kind of confidence interval. So when I say to pick the interval, right now, there's only one to pick from. But we'll have more to pick from. To your question about formulas. The formula you get on the AP test is this structure. You have statistic plus or minus critical value times standard deviation of the statistic. So you'll have to know that this is p hat. You'll have to know that this means z-score. The standard deviation formulas are given to you. So your job is to look at the different standard deviation formulas and say, oh, I want the proportion one. And so stick in square root of p times 1 minus p over n. What you will not get, somewhere, what you will not get is this. You will need to take this, find the pieces, and fill in the gaps. Does that make sense? And that's going to be the case because this formula is going to be the case for every single confidence interval that we do. And we're going to do about 5 of them. But they're all going to have this structure, and you just need to fill in which formula we're using for what. Other questions before I talk about the calculator?
Would a problem like this be an example of like a free response question on like an AP exam?
Yes, usually if they ask you to do this, they might ask one other really short thing, and that's it. Like this would be well, let me go to the slide so I can point to the actual thing that you're doing. Like this 4-step process, that would be the whole problem. And that would be the entire free response that you're doing. As opposed to some other free responses that ask you like 3 different parts about maybe 3 different topics. This would just ask you, make the confidence interval. And that's it. And usually there's at least one free response question that asks you just to do this 4-step process for a problem. And we're going to be spending a lot of time this semester doing these kind of problems. So yes, they are going to be tedious and time consuming, but I think people also find them to be easier for the reason you're talking about, like this semester as a whole, to be easier because we're just building on one major idea. Let's talk about the calculator. How about the calculator? TI. I want you to go into your stat menu. Most of the time, when you're in the stat menu, we've usually been doing either edit where you put your things in the list and work with your list. Or calc for calculating things like one variable stats or regression lines and that kind of stuff. Now we're going to be spending time in the third menu, which is tests. Here's all the different tests and intervals there are. We're not going to be using all of them, but we're going to be using most of them. We will get to most of them by the end of this year. What was this one again? This was a 1 proportion z-interval. That's why I'm calling it differently from what the book calls it, because I'm matching what the calculator is calling it. 1 proportion z-interval. So we're going to go down to 1 proportion z-interval. Is everyone there? So we're going to 1 proportion z-interval. We're going to hit enter. It's going to ask x and n. X is our value. So in other words, we do not put in our proportion at any point here. We put in how many successes we had, which was how many? 57. Out of our n, 102. We want a 95% confidence interval. There it is.
That only gives you plus. Oh, never mind. Okay. Never mind.
Wait, sorry, can I see the inputs again real quick?
I clicked enter twice on accident.
So to show that one more time,
Yeah. I'm here.
we're scrolling down to 1 proportion z-interval.
Oh, shoot.
That's why I asked if everyone was there before I hit enter.
I went to the first one, number 5, which is the 1 proportion z-test.
That's something different. That's the next chapter. We're going to do those.
So maybe I'm ahead of things.
No.
Well, call me psychic.
I don't think so.
Glad we can compromise.
I'm calling you not correct. All right. 1 proportion z-interval.
Okay. Nice.
How many successes out of our sample size? So this would be the fraction of our proportion. What confidence level do you want? We wanted a 95% confidence interval, so 0.95. And then we go to calculate. There it is.
I'm just so glad you spent so much time yesterday. For once, I'm glad I put my homework.
You know how tedious it is typing up that equation in the calculator?
Oh.
Here's the important thing. What you still need to do, just because we have the calculator, doesn't mean you don't need to show things on the paper. You cannot go straight to here. If you go straight to here, then they're not giving you credit for step 3. That's why I said at the start, the 3 things you need: formula, plug in the numbers, answer. So what that means is that you still need to know this formula and fill in the pieces. You still need to show this work. You still need to know how to get this z-score of the 1.96 out. Notice the calculator did not give that to you. We need to go somewhere separate to get that. The thing this does save is having to enter this part manually into the calculator. What it does not save is you still need to write all this out.
You won't get credit if you just do a generic like statistic, plus or minus, critical value, time.
No, they want to see the specific formula that you're using. Other questions? How are we feeling on this? Can I throw something else at you today?
Yeah. I feel like this problem very much walks us through the process with holding our hand, you know? Because it gives you exact numbers and like
Yes.
it literally says this is how many you get that are 10 years old.
An astute observation, Marley.
Well, it does.
No,
All right.
Oh,
We're gonna use the formula in a little bit of a different way. So we have this formula. There are two different ways that we can control for the margin of error. We talked about this in the first section. Two different ways that we can control for the margin of error. Number one is that we can control our confidence level. We can say, instead of an 80% confidence interval, I want a 90% confidence interval, or I want a 95%, or a 99% confidence interval. That would change our margin of error because that would change our z-score that we're using. So that's one thing we can control. We cannot control what we get for our sample proportion. That's just whatever sample we happen to get. The other thing we can control is the sample size. And remember, the larger the sample size, the narrower the interval, because larger sample size, smaller spread, and narrower interval. And that is something that we can pick before we take our sample, is our sample size. So, here comes the new thing to throw at you. If we want to control for a specific margin of error, let's say we do a proportion and we don't want our margin of error to be above plus or minus 2 percentage points. Then we can pick our sample size based on the margin of error we're looking for. And I'll come back to this in just a second. Let me show you the example that we have. All right. Okay. 493. Let's see what we have on 493. I will read you what we have on 493. Company has complaints about customer service. They intend to hire a consultant, et cetera, et cetera. Degree of satisfaction, and they want a margin of error of 3%. Okay. So if we want a 95% confidence interval and we want a margin of error of 0.03, we have, what we're going to do is we are going to say, I want a margin of error of 3%. I'm going to show this setup. And then I will show the rest of like the details and stuff tomorrow. What we can do is we can say, I want a margin of error of 0.03. And so I'm going to put 0.03 in for my margin of error. And on the other side, I'm going to put my z-score formula. So 0.03. I want that to equal square root of, z-score times the square root of p hat times 1 minus p hat over n. And I want to know what sample size I want. I want to solve for n. Well, guess what? I know my z-score, I want to be 1.96 because I'm using a 95% confidence interval. For p hat, we have two choices. If we have a good estimate or a good idea of what the proportion should be, then we can use that for p hat. If we don't know, then the absolute largest that this can get for the standard deviation, you can play around with decimals and see that the largest I can get is if I had 0.5 times 0.5. To be 0.25. Any other proportion is going to be smaller. So if I want to put a high end cap on the margin of error, then the highest end that I want is going to be 0.5. And so I can use 0.5 as that'll give me the largest margin of error I could possibly have. So we're either going to use our established proportion we already have, or we're just going to use 0.5 as our stand-in. So we're going to use 0.5 as our stand-in, and then we're going to do some algebra to solve. Oh yeah, baby, here it comes. And then I'll have another homework assignment in just a second.